Before we get into some new content, why is it all so loud? Before we get into some new content, let's talk project a little bit. I don't want to go into too much detail on the project, but if anybody has specific questions, I'd be absolutely thrilled to answer them. I don't want to get in a spot where I'm reading stuff to you. I only like to do that on day one. But the requirements are here. I got rid of that note that says requirements to be added. I'll briefly skim through this and then answer any questions, and then we can get into some content. Yeah, I understand Google Docs. Frig. So you will use a web framework for the project, as opposed to your homework where you're starting with a TCP connection and then effectively building your own framework. So you do have to use a web framework for this project. And furthermore, you have to use one from this list, or if you want to use one that's not in the list, let me know by whatever means you have. Email me, Discord, Slack, or not Slack, I guess, but get the information. If you talk to me after class, if there's another one that you want added to this list, let me know. I'll decide if it should be on there or not, and more likely than not, I'm going to add it to this list. But it does have to be on this list. It has to be approved. There's only one framework I have in mind that I would not approve, and that's Spring with Java. So if you're looking for that one, you can still talk to me and plead your case, but I'm probably going to say no. That framework, it's a fine framework, but it works based on pure magic. And any team who's used it has not done well because they don't understand it, because you need to submit open source reports, yes, and explain how the technology you use works. If you've heard of these open source reports from other people who took the class, the requirement has been changed a little bit this semester. The reports themselves are the same. I'm not going to go over them right now unless people have specific questions. But you are required to write exactly 3 reports, one on TCP connections. How does the library you use actually create a TCP server? How does the library you use parse HTTP headers? And how does the library you use or libraries manage WebSocket connections? So 3 required reports. You must write reports. If you've heard anything about this class, that is a big change. 3 reports exactly. The TLDR of reports is you got to understand how the technology works, and you actually have to go into the code of the libraries you use and show me in the code where things work. Spring, for example, works off of magic, and no team's been able to find that code. They don't do their reports, and they get zeros on the project. And it's sad, and I don't want to see that to anybody else, so I would veto that thing. Checkpoint, you got to use Docker. You do have to deploy. There are free services, free things you can use. I recommend the GitHub Student Developer Pack. If for whatever reason that's an issue, I do have something I never really have to mention, but now I do. I have a policy in all my courses where you don't spend extra money to take my courses. You already spend money on tuition. You're not going to spend more money. So if you can't find a free avenue through this GitHub Student Developer Pack, most likely would be the case of everybody on your team has already used their developer pack and used all their free credits and everything. If you're in a situation like that, let me know. I'll work with you. We'll figure something out. But you do have to deploy to a domain name. This is something I was sad. For a few semesters, I didn't have this. And you build these projects, and then towards the end of the semester, students come up to me and they say, we learned a bunch of cool stuff, but how do I actually get my website out there to people? I want to make sure you all go through that process, see how that works, because we're building these web apps that can easily be deployed. I want you to actually go through that and have your work out there. You're going to build this beautiful project that you invest tons of hours into and that you're passionate about, right? I can't even keep that up. But you're going to do a project anyway. Deploy it out there so you can send somebody a link. Hey, go to this link and check out my app. Send it to your parents especially. That was going through college. My parents would always be like, so what are you learning in college? And I never have a good answer. It's computer stuff. Hold on. Do you have a few hours? Let me explain polymorphism to you. I can't really do much. But if I can just send them a link and say, hey, I built this cool thing. Check it out. And they just click on it and they can see what I built. I think that's more powerful. So So we're getting deployments back. I've required it on and off over the years, and I'm back on this time. And finally, the project requirements. Again, not going into much detail, but there are, unless there are questions, there are 4 projects you can choose from that each have listed features that you have to implement. They're intentionally somewhat vague in order to give you flexibility in how you build it. As long as you satisfy these requirements, you'll get credit. And then it's up to you what to do. Do I have these things on separate pages, or do I have a profiles page, or how to organize things, what exactly you're implementing. That's all up to you, as long as you satisfy the requirements for your project. So you can either build a game. It has to be a multiplayer game with lobbies and leaderboards. The multiplayer action needs to be live via WebSockets. Other than that, you can build whatever game you want. And just because I know this is going to end up happening, I might as well just advertise it right away. The game can be pretty simple. If you just want to build rock, paper, scissors, but you do need multiple lobbies, multiple games going simultaneously, the game itself can be pretty simple, or as complex as you want it to be. But it does have to have lobbies and multiplayer over WebSockets and leaderboards. So like if you use tic-tac-toe, your leaderboard would probably be how many wins that player has. Who has the most wins overall? E-commerce / auction house. I didn't know what else to call this. It's not quite purely e-commerce, but letting users sell items to other users. I guess it's like a garage sale site. I didn't really know what to call this one. But users are able to sell items. They can make postings, and then other users can purchase those postings. And importantly, you need to have a shopping cart implemented, so somebody can go to the site and buy multiple items from multiple other users, and then click checkout and buy them all in one go. That shopping cart needs to be stored in your database. If a user logs off, your server restarts, that shopping cart must persist. And then also auctions. So instead of just posting an item for sale, users can also post items for auction, and then everybody in that auction can bid on it live via WebSockets, of course. All these projects will have a WebSocket requirement. Can bid on the items, and then at the expiration time of the auction, the highest bidder purchases that item. Top Hat. Building a Top Hat clone. I could probably just say one word and leave it at that. Y'all know what Top Hat is. But Top Hat does have a lot of features, so what's actually required? Any user can create a course. Users can join that course, and then you can post questions to that course. The gradebook, the instructor seeing all the grades, students seeing their grades for each course they're enrolled in. All those features have to be there. And when the question itself goes live, the instructor will create the question, submit what the answer is, submit a time limit for that question, and then that question goes live to all the students, and they can submit their answers via WebSockets, and also the timer counting down needs to be sent to all the students using WebSockets, so they can see the live timer from the server. Submit their answers with WebSockets, and at the time that the timer runs out, the server shouldn't accept any more answers. It's a pretty standard Top Hat functionality, just for creating courses and then opening questions for those courses. Standard from Top Hat perspective, building it, of course, much more complicated. And finally, fantasy sports, where users can join multiple leagues. Users can create leagues, join leagues, and start leagues. When a league is started, you start the draft. Your website needs a roster of players, and then you start the draft, randomly assign an order to your users, and they can pick from the overall roster to get their individual rosters through that. And then after the draft, you can submit the results for, say, each week of the sport. It's football season, so I always think this is football. After each week, you submit all the results, all the stats for every player, and then it should compute all the scores and show a leaderboard of who's leading in each league. And you need multiple leagues simultaneously, and be able to view all the stats and all the stuff. I think I already said that. And those are the 4. And then security, if you have any security issues with your app, consequences can be pretty severe, up to a 0 for the entire project, depending on the egregiousness of the security vulnerability. All right, with that, any questions at all? Boo, go Chiefs, screw that. Go Bills. Looks like no actual questions in there. Anybody have a question? Yeah.
Is there an API for the sports app?
No. So there isn't. You would be building that. The TAs and I were talking. One of the TAs might get some, like maybe in CSV file or JSON or something, get some sample data, just so you don't have to farm data for a long time. But if not, it would be up to you to get the data and build that API. You'll be building the API regardless. You should have like a button. Even if we release something, it'll be like CSV, and then you have a button like upload results for the week, and then send that CSV, and your server would parse through it and get all the results where they need to go. Or if you want to hook up with an API that is out there already, I don't know what exists for any sports, but if there's an API out there and you want your server to just connect to that API, that'd be really cool, actually. It'd be super dope. But if we don't end up providing data, it'll be up to you to figure that one out, up to each team. Yes? It depends exactly what you mean by that. What are you looking for? It's something to get the data for the drafts? That would be fine, yeah. If you're getting data and populating your site with that data, especially for the fantasy sports, absolutely. Getting that data isn't really part of what I need you to get out of this course. And using an API, honestly, would be. I'd be thrilled if you used an API for that, actually. Yeah. You can do it for any sport you want. I was just thinking football when I said, because I almost put in the description. It was hard for me to write the description because I want to say after each week you upload the results, but if you're doing it for something like baseball, it's not really by week, so you can use whatever I want. Just I was thinking football when I was giving the explanation. You can use any, you can use any sport you want. You can even make up a sport. I don't care, as long as you build the features here. You can do whatever you want. Jesse. Bless you. Anything else? Like I said, the doc is live. I got rid of that note. For those of you who checked, there was a note here that said this section will change and expand. It's done. I'll modify this a little. Like as I get questions, I might modify this just to clarify, but I won't change the requirements. I'll just change the wording to be more clear. If I get a common question a couple times, I'll update that. But this is what the requirements will be. I'll stick to it. It's out there to you. So once something's released to students without a note like that, I had, I'll stick to it. I'm not going to change it. So if you want to start planning your projects, I don't want to change things out after you got halfway through designing your project. I'll only update wording. But this is available. Team meeting form is live. Team formation form has been live. Oh, I do want to talk about that. Requirements, this is just a redundant link to that same document. The report template, if you want to take a look at how the reports are going to go, which I'll save that for later before I start talking about that in lecture. And then how the presentations are graded. All the information for the project is out there. It's all live. I want to make sure it was all live at the very latest by today because you're about to start meeting with your team. So it's all out there. Yes?
Everybody on the team got to fill out the team formation?
No. Just one. So team formation. This is the one I do want to talk about. If you haven't formed your team yet and you do want to, the deadline is tonight at midnight. So tonight at midnight is when I can first start. Like I might be asleep by midnight. I don't know what's in store for my night. But probably tomorrow, I'll start processing these. And anybody who's not on a team is going to be assigned to a random team. So if you just want a random team, don't do anything. But if you want to be on a team, if you don't submit by midnight, and by submit, I mean your UBIT must be on, did I say UBIT? Yeah, UBIT email team member. So if your UBIT isn't on a submission of this form by midnight, you're going to be put on a random team. So just please keep that in mind. Anybody who comes to me tomorrow and says, oh, I didn't fill out the form, or I thought my friend was filling it out, or whatever, you're getting on a random team. Like you're not getting your team. So just make sure you fill out that form. Like if the people talking back there don't fill out the form because they weren't listening, I'm going to put them all on separate teams. Like I don't care. I'm not dealing with that. So just make sure you fill that in if you have your team formed. I don't think I mentioned this, but I did activate the Piazza post for finding teammates. And there's also the Discord. So you have a few avenues to find some classmates interested in similar things as you. But make sure you submit by midnight. Yes?
Can we change our team name further along the line if we want to?
Sure. Yeah, send me an email if you want to change your team name. I'll say that's the protocol. I don't use the team name for too much. I guess for talking to the TAs and then for the presentation schedule. Usually when I release the presentation schedule, I get a bunch of emails because people forgot their team name. Okay, everyone clear on all the project stuff? Fuck, that was 20 minutes already. Everyone clear on all the project stuff? So submit your team formation by midnight, or else you ain't getting your team. Everybody understands that. And the reason I have to be strict with that deadline is because the students who are going on random teams, like they need to know because they need to schedule a meeting for next week. So I can't just dawdle on that and say, oh, take your time. Like I need to do that like Saturday morning at the latest. All right. Multi-part parsing and file upload. So last time I showed you that format really quick of multi-part form. Today we want to talk all about that format. So we saw forms. We changed this encoding type to multi-part form, and we got requests that were multi-part form encoded, which looked like this. So we want to talk about parsing this, but before we get to that, I want to talk about file uploads because it's a much shorter conversation. But this is required for file uploads. If you try to upload a file without multi-part form encoding, your file will not upload. What you'll get instead is the name of the file that was submitted, which probably isn't what you want. You probably actually want the contents of that file. So if you want the contents of the file and you want to submit them using an HTML form, you have to have an encoding type of multi-part form data and a method of post. If you don't have those two things, your file doesn't upload. If you've built a site, I mentioned this Wednesday, but if you built a site using file uploads, using libraries and frameworks and everything, you got to a point where the files just weren't uploading. You weren't getting the contents of the file. Probably happened, maybe it didn't, but you might have gotten to that point. And after a while of debugging and searching Google, you realize, oh, you have to put this on your form. It's because you have to do that. You just have to do it. Whether you're using libraries, frameworks, or starting with a TCP socket like we are, you have to. The browser isn't going to send the data of the file, the contents of the file, if you don't have multi-part form data and a post. Once you do have that, instead of text, we just say type file, then that's it. That's it. Your browser is going to read that and give you a file picker in the browser. You click it, it opens your file system. You can choose whatever file to upload, then you upload that file. You just change text to file. That's it. You support file uploads on the front end with just that change. That's it. Front end handles file uploads. It's going to send files to your server. What we want to focus on the rest of the time is how does your server take this request and actually get the contents of that file. So for homework 2, this is in the context of image uploads. So for homework 2, you have to support image uploads. The front end, the form, it's already given to you in the homework handout. But when you get that request, you have to take the bytes of that image and save it to a file so you can serve that image to other users. Homework 2, you're basically building a file share, not general file share, but an image share, an image bulletin board, kind of. I think of it as a 4chan clone. But you can upload images, and those images are shared with other users. So we need to get the bytes of that image and save it to a file so we can host it to other users. So let's talk about how to do that. We're going to get a request that looks like this. Each part of the form is going to be a separate part of the body of the HTTP request, and it's going to contain all of the bytes of the file that was uploaded. Of course, this is where the actual bytes would go. The file I uploaded was, not huge, but even a kilobyte is not going to fit on the slide. So I'm just going to put a placeholder there for what it's worth. When we get the bytes of this file, especially since it's an image in our homework, it's very important that we never convert it to a string. I hope you're getting sick of hearing me say that by now, because I want to make sure I hammer it in everybody's head, but you cannot convert it to a string. This was true when we were hosting files in homework 1. We would make sure that we convert the headers to bytes. Oh, of course, some of you are probably still working on homework 1. We convert the headers to bytes, and then concatenate the bytes of the header to the bytes of the file using byte array concatenation. Combine those two bytes, byte arrays, and then send it over the server, over the internet. It was important to do that because we can't convert the image to a string. It wasn't too hard in homework 1. There were some extra things you had to do, extra steps to do, but not too complicated. But now, when our bytes of our file are nested in all of these strings that we have to parse, it gets a little bit tougher. But the same rules apply. We can't convert the contents of the file into a string. If we want to support general file uploads, if we want to support file uploads that aren't text, well, which we do. So we can't decode them as strings because they're not going to be UTF encoded. They're going to be JPEG encoded. They're going to be MP4 encoded. They're not going to be necessarily UTF-8 encoded. So we really have to be careful with that, and we have to parse this thing in bytes instead of strings. There's a lot of what would be string parsing in this, and we have to do that stuff in bytes. So this gets fairly tricky, gets pretty challenging. The bulk of homework 2 is going to be parsing this format. And then once you do parse this format, that's like objectives 1 and 2 pretty much done. But it is a lot of work just to parse this format. And the rest of the homework, in my opinion, is downhill. It's pretty much easy after you're parsing this format properly. Though there can be snags. So let's take a look at this format. First, you're going to treat this like your GET requests, kinda. We'll get to that. We're going to treat this like your GET requests, except you have the bytes of a file, the bytes of an image sitting down there. So you can't just convert the whole thing to a string. But you still need to read the header line, the request line. So the request line, if it says post/form path or whatever your path for your form is, that matches your HTML. In your HTML, you have the path that you set in action, right? In action is going to be the path. So if that request is for the path from your form that you put on your HTML and it's a post, you're going to say, oh, this is a form submission request. Let me go into all my form parsing code and handle this request. We're going to read the content length. Content length is going to gain a lot more importance. It's extremely important when you were sending HTTP responses to get your content length exactly right. It's extremely important here to make sure that you're reading all of the content. This is going to be, I'll expand a lot more when we get to the buffers lecture, but you need to make sure that you read this many bytes. If this content length is 9937, I got to make sure I read 9,937 bytes of information, or else I haven't read the entire request. And that's information after the blank line, after the headers. So if you haven't read that much, the TLDR for now is that you have to go back to your TCP socket and grab more information. In Python, this is calling that receive method again until you get all of the data, until you get all of the information. Very, very, very important. That'll talk about in more depth. The content length is just the content of the body. It doesn't include the headers, and it doesn't include the /r/n/r/n. There's 4 bytes right here for this blank line. It doesn't include those bytes either. Everything after that is content length. That's content. So this is going to be exactly 9937 bytes, where most of it I have this placeholder for the bytes of the file. This was an actual request, by the way, that I created and deleted all the extra headers that we didn't care about. Very important. This will be starting with Objective 2. This will be important. If you're testing in certain browsers, which includes Chrome, so most of you, Chrome won't always, I don't know if I've ever seen it, but it won't send the body of the request with the headers. It'll send them in 2 different parts. So the first time you read, you're only going to see headers. And then you read again, and then you'll actually get the body of the request. When a file is being uploaded, it does that. Almost certainly for performance, but it gets annoying. The next thing, content type, is going to look a little different. The content type is going to be this multi-part form data. And then using the same syntax we used to specify char set equals UTF-8, for the same thing way we did that UTF-8, we're going to have that same syntax, which is going to define a boundary. This boundary is going to be what separates the parts of the body. So if you don't have that general header parsing code, if you do have that, you don't have much extra work to do here. But if you don't already have that, there's another header you have to parse. I strongly recommend, right from homework 1, write a method that's going to read all of your headers and put them in a big key value pair. So you're not writing header parsing code all semester. You want to be still writing header parsing code in homework 4. You just want to call the method you wrote in homework 1. Save yourself a lot of time. So we have another header we have to parse, and then we have to parse this format as well and get the boundary. That boundary separates the parts. So we have 2 separate parts for this request. For the form that we saw, the last HTML form we saw, that's what generated this request. We have one part for the commenter, whatever the user typed into that text box, and then another part for the image upload, which contains all of the bytes of that image, and they're separated by that boundary. Oh, yeah, I forgot to mention the lecture questions. I'm more than a bit behind on lecture question grading. I was going to get it done this morning, but I ended up spending the whole morning finishing the project documentation. I'll get it done shortly, within the next day or 2. Yeah.
Is that just like a random sentence to prevent it from reasonably accidentally being
Yes.
being accidentally replicate by another program?
Oh, yeah, not necessarily. Yeah, kind of. The string, the boundary.
Yeah.
So it's generated by the browser in such a way that it is not contained in any of the content. Because if it's contained in any of the content, it's going to mess up our parsing. So it cannot be contained in any of the actual data. So it does have to generate these dynamically, and they do end up looking pretty crazy, just to make sure that's the case. There's another question, yeah. Yes, so right here, not there, and right here, there's a /r/n. And yeah, and right here, and right here. want to like show you one of these with all the bytes shown, but it's all one big long line, it gets messy for a slide. But yeah, there's /r/ns. There's the 2 right here, so this one just uses the second one for that separation. Then there is an extra one here, an extra one here, an extra one here, an extra one here, and then not one here. Optionally, there can be, actually. The browser's allowed to put one here, but it doesn't have to be. And it wouldn't have meaning if it was there. So when you're writing your parsing code, you want to look for this boundary to find the separation of the parts. When the boundary is being used as a boundary of parts, and some of this drives me a little nuts, but it is what it is. When the boundary shows up in the body of the request, there are 2 extra dashes appended to the beginning of it. So you're not looking for the boundary itself. You're looking for a dash dash and then the boundary. And the boundary always has to be on the start of a new line. So if it's not guaranteed to be the start of a new line, there's going to be a CRLF, that /r/n right before it. So this one already has a CRLF right before it because there's guaranteed to be a CRLF right here. So this won't be necessary. There won't be 3 CRLFs here. You'll just see one of them, the dash dash, and then the boundary. But it does need to be on the start of its own line, and there will be a CRLF right here, just like this were the request line. There's a CRLF before we start talking about headers, which I'll talk about in a second. This has to be on a new line. There's no guarantee that whatever the user typed in ended with CRLF. It's almost guaranteed that the user didn't type /r/n or anything. So there will be an extra one right before this boundary as well, and this one as well. So there will be extra CRLFs. The important part of that is when you're reading the bytes of this file, don't take this CRLF right here. Don't append that to the end of your image bytes. Don't save that as part of your file. It's not part of the file. The last boundary is handed as a special case. Same as the other ones, except it has a trailing dash dash as well. If you see that trailing dash dash, that means this is the last boundary. There's nothing of import after this thing. There can actually be extra information. I've never seen a browser do this, but the browser's allowed to add extra information after the last boundary, which is why we put this dash dash instead of just saying, well, the last time you see it, that's the end of the content. The dash dash says this is the end of the content, and whatever is put after this is the browser putting dumb things or whatever it wants to. Yeah.
But the extra CRLF means the one that makes the clear line, right?
Yeah.
I mean, like when you
Like there will be all the bytes of the file, and then a CRLF, and that's what makes this on its own line. Because the boundary always has to be at the beginning of a line, so there's an extra CRLF appended to the end of the bytes of the image in this case to make sure that that's the case. So effectively, the boundary is CRLF dash dash boundary dash dash for the last one at least.
But then the body is still separated by RF, by CRLF and CRLF.
Mm-hmm. And I'm about to get to that too. So the inside each part, it's going to be just like an HTTP request. It's the same format. It's any number of headers, well, except for there's no request line. Any number of headers, which could actually be 0. It won't in our cases. Any number of headers, CRLF, and then the content for that part. So we have 2 headers in this case, our CRLF, and then the content for that part, and then a CRLF, and then the next boundary. So when you're parsing, it's important to extract exactly the bytes of that image. So we want to make sure we get exactly those bytes and not these extra CRLFs, not the CRLFs here, no headers. We want to get just the bytes of the file. Yeah.
Is the encoding for the character running line speed because of those things, or why wouldn't it be line?
Because that's the standard. So when HTTP was created, it was back in the day. It was Windows, it was typewriters and stuff. It was just the way. So once HTTP was written like that, we were just stuck with it. So it's all line feeds and new lines. Or carriage return line feed, rather. So these headers are going to include content disposition. Because we have a form submission, we're going to get this content disposition. Not strictly required by the standard, but since we're using this for form submissions, we're going to have these. So this content disposition gives us, most importantly, the name of the value that we're reading. And again, this is where your generic header parsing code is going to come in handy. Just throw this in your header parsing, read the content disposition, and grab the name value. So the name is going to be the name of the form element, whatever we gave it. Commenter, and I named that upload. If we go way back, I almost put the form there. Commenter and upload, whatever name you gave those inputs, that's what's going to show up in this header. You're going to get the name so you can know what part you're looking at. For files, for what it's worth, you get the original file name, which in most cases you don't want to use. You don't really care what the user named their file. You're not going to use that file name anyway. Whenever you upload a file to the internet, you notice that you get some long ID for that file name. It's never named whatever you named it when you request that file again. Yeah.
Do you have any recommendation? Is there like any specific methods of reading headers, or do we just use like plain, do we just use plain comparisons and stuff like that?
Yeah. I mean, you can use regex if you want to be fancy about it, but yeah, just use regular expressions. But I'd recommend just using like string.split as your friend when you're parsing headers. Split on new lines, kind of split on colon. It's a little dangerous. You should look for the first instance of a colon in case the header value has a colon in it, and just parse it that way.
So we will have to read through it and stuff?
Oh yeah, you'll be reading headers all semester. This is not the end of headers, just everything we do. I mean, HTTP is all about headers. The longer you go, I've seen students try to cheese it throughout the semester, try to go, without actually writing a general parser, header parsing code method or anything, and it just gets harder and harder as the semester goes. By the time we get to authentication with auth tokens stored in cookies, they get to that point and they just completely fall apart. They're in office hours going, how do I read this cookie? Well, you call that header parsing code your own homework going, I never did that. Oh, what do you want me to do for you then? You ignored my advice 100 times. You're not going to come to me for help at this point. So, yeah, just write that code, please.
What does a header parser do? Just split the header?
Yeah, it just splits, you give it these headers, these two lines. It'll split them on CRLF to get each header. Look for the colon, eliminate this space, and throw it in a key value store. Like a Python dictionary. I want a dictionary with a key content length with the value 9937, a key content type with this as a value. That's what my header parsing code wants to do. And then I can work with that map and do what I need to do with it. But I don't want to keep reading headers throughout every homework. Write that code one time. You're going to call it here. You're going to call it here. You're going to call it here. You're going to get a lot of mileage out of that method. Write it early, and then just start calling it. Saves you a lot of time. And we can optionally have more headers. If we have a content type header, that means the type is not text plain. If there's no content type header, it defaults to text plain. This is just plain text. The first, the commenter value where I'm just typing my name, there's no content type, so that's plain text, and we can treat it as such. It's plain text, which means we don't have any char set UTF-8 either, so it should just be ASCII plain text. This is an image, so we got image/PNG. Notice that there are no content length headers in each part. The purpose of content length is to make sure that we read the entire body of the HTTP request. So this 9937 says, hey, you got to read 9,937 bytes after this CRLF. So I'm going to make sure I read 9937 bytes. And if I haven't read that many, I know I didn't get the full request. It's a check to make sure that we've read all of the information. By the time we're parsing these parts, we already read the whole request. There's no purpose for an extra content length. Content length is just parse it properly and everything that's left. That's going to be the content. So there's no need for it, so we're not going to add it. Browsers won't add it. It's not part of the standard, just not necessary. It's necessary for HTTP requests because if there's a whole bunch of data coming over on the stream, when do I stop reading it? Or when do I know to wait for more? You check the content length. We don't have the same problem here, so no content length. And then finally, after all of that parsing, we've isolated the bytes of the file, and we're able to store it on our server and serve it to other users. And of course, we're never encoding it as a string. The problem is, pretty much everything I talked about in parsing all this stuff was string parsing. So that's where the trick comes in. That's where this becomes fairly hard to parse this stuff. So we want to parse in bytes. We're no longer talking about string parsing. We're talking about byte parsing. And this is different for each language. Time permitting, I might have a demo in Python and JavaScript. But if not, you got to parse in bytes. Bytes. So in general, you have your request comes in as bytes. Don't decode it. If you take your whole request and you hit it with a .decode, it's not going to work. It's not UTF-8 encoded because you have bytes of a file that's an image in there. Starting with Objective 2 on the homework at least. Objective 1, you don't need to do this, but I'd recommend you do because you have to rewrite the whole thing if you don't when you get to Objective 2. So you have the whole request already as bytes, and you know what values you're looking for. The very first thing you would look for example, is this first CRLF. That's the one that's going to separate the headers from the body. So you want to look for that first CRLF, and you want to find it as bytes. So you take your /r/n/r/n, you could even create that as a string, and then hit it with a .encode. Trying to remember if I said encode or decode later. I might have said the wrong one earlier. But
Turning it from a string into the bytes, so you can compare it to the bytes.
Encode this time, and then decode when you're... Don't decode the entire request. You'll encode the /. Yeah, I got that right. So take your string, /r/n/r/n. Fucking brain. Encode it. Change it into a byte array. Change it from a string to a byte array. There we go. And once you have it as a byte array, you're looking for that subsequence of bytes in the byte array of the request. So you're looking for a subsequence of bytes. Python actually has pretty good support for this. It feels a lot like working with strings. So you have a lot of support in Python. If not, you can always look for that subsequence manually, iterate through the bytes of your byte array, and look for that subsequence, and actually find that subsequence, and then that's the location of where you want to be. You'll get an index, usually, where that subsequence starts, and then start splicing your array by indices. Once you have the headers isolated, those you can safely convert as a string. Headers are guaranteed to be ASCII only, so you can easily convert that to a string and start doing your parsing to get your boundary. Once you have your boundary, I think I'm getting ahead of my slides. Once you get your boundary, after separating the headers from the body, get the boundary from your header, which you can parse as a string. Once you get that boundary extracted, convert that to a byte array and do the same thing on the body. Look for that as a byte array, as a byte array, as a byte array. Start separating these parts, and then repeat the process. For each part, look for that /r/n/r/n as bytes. Separate the headers from the content. Parse the headers. Find out what you're looking for. And at that point, after all that parsing, you should have the bytes isolated. Bytes of that file isolated without ever converting it to a string. This does get challenging, gets time consuming. Be ready for it on homework. It's much more challenging than anything you've seen on homework 1. So just be prepared, allocate time, whatever you need to do. It takes a while. Especially if you haven't done byte parsing and you're looking up how do I byte parse in Python, how do I byte parse in Node. It can take a bit. So just plan accordingly, please. And we now support file sharing. I have a few more slides. I'll save them for next time. I don't want to jam them in the end of a lecture because they're about security. It's super important. I'll talk about those at the beginning of the next one. And hopefully I didn't mess up that's not the lecture question. Hopefully I didn't mess up the form like I did in 116, and we can actually submit the lecture question. In 116 today, I forgot to submit the form, so the submission in Autolab was set up, but it didn't give you the A, B, C, D, E options. Just wasn't there, so I had to give them a free one. Nobody complained yet, so I assume I did it right here on this one. And have a great week, and I'll see you on Monday.